Welcome to another edition of Math, Music, and More. If you happen to see, the last video was about proving by contradiction that the square root of 2 was an irrational number. And we did a little bit of a side exercise just demonstrating for even numbers that the squares of even numbers were what I referred to as double even numbers. And I want to go back to that for a moment because when I wrote those things out yesterday, I noticed that there was a little bit of an interesting pattern. So let's take a look. If you remember, we said that if we take m and then we square it, and we use just a few examples, 2, 4, 6, 8, I believe, were the numbers that we used, we realize that 2 squared is 4, 4 squared is 16, 6 squared is 36, 8 squared is 64. But I'd like to point your attention at something else, which is the actual difference function applied to these squares. If you look at the difference between 4 and 16, well, the difference, of course, would be 12. And if you look at the difference between 16 and 36, you'd see that the difference would actually be 20. And if you look at the difference between 36 and 64, you'd see that the difference would actually be 28. And by the way, if you go backwards a little bit, 0, you could consider it an even number, 0 squared. And 0 to this next option, if we included that 0 squared as 0, would actually be a difference of 4. So what do you notice here? You notice the difference of the differences. This is what I noticed yesterday, and I wanted to draw your attention to it. Let's do the difference of the differences. The difference here is 8. The difference here is 8. The difference here is 8. So in other words, every single time we square an even number, the difference to the next iteration of the sequence is the same difference as before with an 8 added. And in the next iteration, it's again the same difference of the prior iteration with 8 added. Let's go ahead and prove that for a moment. But this is such a small board. I'll do a quick wipe down. My apologies. Goes quick. So how are we going to do that? Well, let's just evaluate it analytically. If we were, for example, to consider, we'll call it n now just because I like it better than m. But if we say n minus 2 is one even number, the next even number then, of course, if we consider n to be integers, would be n. And the next even number would be n plus 2. And let's see what each of these things would be squared. And then let's take the difference and the difference of the differences. So we square this, and we square this. And let's see what actually comes out of each of these things. Well, the first one, just using typical FOIL stuff, would be n squared minus 4n plus 4. The next one would just be n squared. And the next one would be n squared plus 4n plus 4. So let's look at the differences then. If you take this and you subtract this, what do you get? You subtract. So if I take this and subtract that, I actually get 4n minus 4. And if I take this and subtract that, I get 4n plus 4. Now let's take again, as I mentioned, the difference of the difference. What do you get? Well, this minus this would just be 8. And hence, analytically,